So the last piece of this section is the fact that chirality can also have an effect on spectroscopy. And that's because we can define any two protons, especially when we're talking about protons on the same carbon, as homotopic, which means they're equivalent in every possible way, and antiotopic, which means they're chemically equivalent, but optically different. Now these two won't really affect our NMR spectrum. But if two protons are what we call diastereotopic, then they are in fact chemically different. Now, how do we determine this relationship? Well, let's say we're looking at these two protons. And what we're going to do is we're going to replace each of those protons with something else. So down here we'll replace the one on the left. I'm using bromine, but we could use literally anything. And over here we'll replace the one on the right. Now, if we determine the stereochemistry of these two molecules, we find that the one on the right here is R, and the one over here is S. So because one gave us R, one gave us S, what that means is that these two protons are in fact enantiotopic. Now that, again, won't have an effect on our NMR spectrum. And if the two resulting molecules that we had drawn had been identical, we would have determined those protons to be homotopic. But the reason that this matters and affects an NMR spectrum is if we look at these two, HA and HB. And if you take a couple minutes and, again, do the same thing we did and swap each one out for a different group, you'll find that in that case you get diastereomers. And if you get diastereomers, that will define these as diastereotopic. And diastereotopic are not chemically equivalent. Well, if they're not chemically equivalent, then they will cause additional splitting. And so if I asked you, what's the splitting pattern for HA? Well, HA is split by this CH3 to its left into a quartet. But HB, even though HB is on the same carbon, HA, because it's diastereotopic with HB, they're not chemically equivalent. And so HA will also be split by HB into a doublet. And so as you get into chiral molecules, this idea of chirality as well as diastereotopic can really have some important impacts on splitting patterns. But again, I just want to make sure we make it clear that it's only in the case of diastereotopic. Enantiotopic and homotopic have no effect at all on the splitting patterns. So to finish up this chapter, there's an in-class exercise, number 16, and that's what you will want to go ahead and work on next.